In this video, we'll be using the derivative to find the equation of the tangent to a curve at a particular point. In the last lesson, we saw that the derivative will give us the slope of the tangent line at any point on the curve. We can then use a given point to find the equation of the tangent line. In this example, we're asked to find the equation of the tangent line of y equals 2x squared minus x at the point 2, 6. By differentiating, we will be getting the gradient of the tangents to that curve at any points. And we want to find that gradient at a specific point where x is 2. So we'll substitute x equals 2 into our equation for the derivative to find the gradient at that particular point. And that works out to be 7. So that'll give us the gradient of the tangent line at the point 2, 6. We now have to find the equation of that line. There are two approaches we can take to find the equation of that line with the given gradient. We can use the equation of the straight line as y equals mx plus c, and we know that the gradient is 7, so we'll substitute the 7 in for the m to get our equation of the straight line, but we still have to find the c. We know that the line goes through the point 2, 6, so we can substitute y equals 6 and x equals 2 to get the value of c. So putting the 6 in there for y and the 2 for x there, we can then solve that for c to get c equals minus 8. And that gives us the equation of the tangent as y equals 7x minus 8. In the second approach, we'll once again use the fact that the gradient is 7, and we'll express the gradient as the change in y, or the rise, over the change in x, which is the run. And one point we'll consider is the point xy. Now that's just some general point on the line. And we'll also use the specific point with the coordinates 2, 6 that we were given. So we'll put the 2, 6 into that equation. And now we've got an equation with x and y in it only, and we can rearrange that to get our equation of the straight line, multiplying up by x minus 2, and then expanding the brackets, and then putting the y by itself there. We'll get the same equation that we got before. So we've seen that we can find the equation of the tangent by finding the derivative of the function firstly, and then evaluating that derivative at the given value of x. And that'll give us the gradient of the tangent line. We then use that gradient and the given point to find the equation of the line.